So differentiate the function with a natural log. Now, this one is specific to chain rule. So, oh no, I'm on the highlighter. It's the wrong pen. Here we go. So what this tells us is, again, if you know that ln of x goes to 1 over x, then ln of a function is basically chain rule for logs. And again, people mess this up and it becomes a problem in integration. We want to be clear on what we do with this. So let me just show you very quickly. So basically what we do is we know that ln of a thing goes to 1 over the function, 1 over the thing. That's how you differentiate ln, goes 1 over x. So if it's ln of a function, it'd be 1 over the function. And then what we're going to do is we're going to times by the derivative of the inside, as it's a chain. So ultimately, ln of a function basically just becomes the derivative over the thing. And that's how I learn it, because it helps for integration, learning that sort of as a process. Okay, few other key bits to go over. This sort of situation here, I'm just going to show you how you deal with these. Remember that ln kx is the same as ln k plus ln x. So that is actually precisely why when you differentiate it, ln k would be 0, and you would just get 1 over x as well for ln 5x, ln kx, because that constant would disappear. And even if you chain ruled it, you'd get k over kx, which would simplify to 1 over x. This one's a little bit strange. So we could write this actually as a product from log rules. And then if we differentiated it, we would get 1 times ln x plus the other way round, x times 1 over x. And so the answer to this one is actually ln x plus 1. Okay. So these were some good questions to go through. I'm going to push on to some exam questions now, just so we can get time to go through a bit of implicit as well. I'm actually going to just guide us full steam ahead through this one. So please try and make notes, just so that we can allow a bit of a break as well. So by finding dy dx, give the values of x for which the function y equals 3 to the x squared is an increasing function, right? This looks pretty epic. Let's have a little look. So we look at exponentials. We're looking at dy dx. So here we go. So this is what we're doing. Right, determine dy dx. So it's a chain. It's 3 to the x squared. Now, ultimately, it's a 3 to the something. So 3 to the something goes to 3 to the something ln 3. That's the thing we just mentioned. A to the x differentiates to a to the x ln a. Okay, and inside that function was x squared, which differentiates to 2x. So if we put this together by chain rule, then we know that it's ln 3 times 3 to the x squared, and we're going to need to times by the derivative of the inside, which was 2x. So that is your answer. So that was quite a nasty one. Get it down, though, because there will be some other questions in the practice mini mock at the end where you can consolidate this, and you can kind of rework towards that answer. What we'll do is we'll kind of go full steam ahead, as I said, onto the implicit. And now implicit differentiation. Let's see how we go with this. So there's your answer. When is it increasing? Basically for all those values. So all values of x greater than 0.